what you should be doing, since we won't meet again tomorrow, I won't be able to remind you again. But over the weekend, you can find, just like with exam 1, exam 2, I have a practice test. So over the weekend, it would be good for you to download that, take a look at it. The test covers all that stuff we did with decimals, fractions and decimals, means, medians, a little bit of probability. That was all Chapter 5. Then we did unit rates and ratios, and then proportions and percentages. So I would check that out over the weekend. So then on Monday when we come back, I'll just answer any questions you have. I'll go over any of those problems for the practice test that you want to take a look at. But it's best if you've at least taken a look at it, even if you haven't done the whole thing. It's best to at least browsed it to see what types of problems you'd like to go over in class, because I'm not sure we'd have time to do the entire thing. So it'd be just like last time, though. So any questions about the test or anything like that? Okay, so no class tomorrow. You can come, but I won't be here. All right. Let's go to where we were at yesterday. Excuse me. So yesterday, I had given you these applications of proportional equations. And so I'll just go through these. So the first one that we looked at there, it was talking about producing fenders at a certain rate. So the problem said that in 3 hours that the technician could produce 17 fenders. And then my question was, then how long would it take to produce 50? And I said to round to the nearest tenth of an hour. So when you set up your proportional equations, the first step is you always want to set up like an initial proportion or fraction. So you can do it either way. It doesn't matter if you put fenders over hours or hours over fenders. You just have to be consistent. So here it's 3 hours to 17 fenders. So I'm putting hours over parts, right? And so then when I set that equal to another fraction, I just need to make sure that I'm using hours and parts, in the same way. So here, the question was how long to produce 50 fenders. So should 50 fenders go on the top or the bottom of my equation? It should go on the bottom because I put fenders on the bottom in the initial fraction, right? So then what we don't know is the hours, so we just put a variable there. So we create the proportional equation, and then we can solve it by cross-multiplying. Okay, so then we would multiply our 50 up to the left-hand side and our 17 up to the right-hand side. So 50 times 3, that's 150. And on the right-hand side, we'd have 17. And then the last step would be what? We would divide by 17. And so our answer would be, whatever 150 divided by 17 is. And that would be our solution. So what does that come out to be? What's that? 8.8 if you round? Yeah. Did it even need rounded? I don't even, yeah. What did it come out to before you rounded? 8.82. 8.82. Okay, so it'd be 8.8 hours. So just under 9 hours is how long it'd take to produce 50. Okay? Is this right here, is this the only way it could have been set up? It's not. Did anybody else do it the flip side? Yeah, some people may have done it the opposite. Because if you set up your initial fraction, you can set up the first fraction 17 to 3, like putting fenders on top and hours on bottom. It's totally fine. You just need to make sure that your other fraction matches. So if fenders are on top on the first fraction, they should be on top on the second fraction. Because then when you cross multiply, you're going to end up with the exact same equation, right? Yeah.
Would you then round it up to
On the question, I just said round to the nearest tenth of an hour. So I try to always remember to tell you to round when you got around. So yeah, I would go tenth on that one. But yeah, if you're rounding the whole hour, then it'd be 9 hours. Yeah, that's okay. All right. Any questions on that one? So the key is set up your initial fraction, put an equal sign, set up your second fraction, and make sure that you're consistent from the first to the second. All right. So then the next one is 18 pages per minute. This one you could actually do without proportional equations. You can do all of these without proportional equations technically. You could just figure out the unit rate, like fenders per hour, or something like that, and then divide 50 by that or whatever. That'll give you the answer. Same thing with this one. But since we're already setting them up in proportional equations, so this is 18 pages in 1 minute, and the question is how long to print 150. Okay, so then we'll just set up our initial fraction. So you could just go 18 pages in 1 minute. And then over here, if I'm doing pages over minutes, my pages should go here. My minutes are unknown. What do you ultimately just end up doing, though? So when you cross multiply, you get 18x equals 150. And then what? You just divide, right? So it'd be whatever 850, or sorry, it'd be whatever 150 divided by 18 is. And I think I said round to the nearest tenth of a minute. What does that come out to be? 8.3? 8.3 minutes. So, is that true? Other people get that? Yeah? Okay? Pretty reasonable? Any questions on either of those two? All right. So the next one is a little bit different. So the idea is you have somebody on a road trip, they're driving, and the total distance from Pasco to Lincoln City is about 315 miles. So they have to cover 315 miles. But then in the middle, they stop at the Dalles, and at that point, they had traveled 2 hours, and they had covered 135 miles. Okay, and so my question was, if they keep driving at that pace on average, how much longer is the remaining trip? Like, so how much time do they have left? Okay. So there's a couple ways to set this one up. The first thing we could do, though, is the initial fraction you're going to set up is the same either way, right? So in our initial fraction, we would go like the 2 hours to the 135 miles. Or you could flip it. It could be 135 to 2. It doesn't matter which way you do it. Okay. Now, what fraction did anybody over here use one? What fraction did you use as your second fraction there? So 2 hours, 135 miles. What should go over here? So one way to set it up is you could say, okay, this is how far we've gone. It's taken us 2 hours. We could figure out the total time, right? Because if this is the total mileage, then this would be the total time. And we could set it up that way. And then once we know how long the trip is going to take, well, we've already covered 2 hours, so then that'll tell us what we have left over. So that's a totally reasonable way to do it. So if we set it up this way, we cross multiply, right? So if we cross multiply, then what does it become? 2 times 315 is 630, yeah? Equals 135x, and then you divide both sides by 135, and so our answer is just going to be whatever 630 divided by 135 is, and what does that give us? 4.7. What is it? 4.7. So it would be 4.7 hours. Now, is that the answer to the question? Because in the question, what did I ask? I asked how much is remaining. Now, this is the total time, right? So if you do it this way, that's telling you the total time it's going to take you to get from one to the other. So how much time do you have remaining? Well, you've already covered 2, so you'd have 2.7 hours remaining. So it's a 4.7 hour trip, and you have 2.7 hours remaining because you've already covered 2 of them. Yeah? Did anybody do it a different way? Is it possible to do it a different way? It is. What's another way you could do it? So we solved for the total time. So we used 315 miles, and so that's why that's why the reason we use 315 miles is because that's the total distance. But what could we have used there instead? If we know how far we've gone, what could we figure out? Yeah, we could think of this, and we could do the preliminary stuff, and we could say, okay, well, first off, let's figure out how many miles do we actually have left, right? So it's a 315-mile trip, and we've already covered 135 miles. So how much further do we have to go? 180 miles to go. Okay, so then when we set up our equation, so in 2 hours we covered 135, what we could do is we could go directly to the remaining time by just using the remaining miles in our fraction, and then that'll get us to the answer. Well, let's see. Let's make sure it works, right? So if we cross multiply, 2 times 180, that's 360, equals 135x. You divide both sides by 135, and so our answer is whatever 360 divided by 135 is, and what is that? I hope it's 2.7. Yeah, I hope it's 2.7, right? Did you get off? I feel like maybe you're off by a decimal place. Should be 2.7. Like that. Yeah, it'll round. I think it's something. I just got a decimal in the wrong place or something there. Yeah. So, I bet you did 36 on accident, huh? Yeah, I bet you just missed the 0 on 360. 36. Okay. Does that seem reasonable? I mean, it must work because you got us the same answer. So, but yeah, it's just two different approaches. It's like, do you want to solve for the total and then work your way back to your answer, or do you want to solve for the remaining distance and go straight to the answer? It doesn't really matter either way. So, does anybody have questions about either of these approaches? Okay. So it just takes you just want to make sure that you read it carefully, because it could ask for the total time or it could ask for the remaining time, and I think there's one like that on your quiz for section 6.5. So just read it carefully. All right. Okay. The last one was a thing about recipes. So then on the last one, it was that there was a recipe for dinner rolls, and for every 1.5 cups of milk, it called for 6 cups of flour, right? And then, so my question was, well, let's suppose that you go in and you go to your pantry and you find out you don't actually have 6 cups of flour. So she only had, what was it, 4.5 cups. All right, well, you could still make the recipe. It's just that you're going to have to scale back everything to go along with it. That's the idea. So you'll just make a smaller batch. So then my question is, if that's the case, then how much milk should be used? Right? So we just set up our initial fractions. So it's 1.5 milk to 6 flour. So I'm putting milk on top, flour on bottom. So then in my next fraction, where does 4.5 go, top or bottom? It's got to go in the bottom because it's milk on bottom here, so it should be milk on bottom here. I'm sorry, flour on bottom, flour on bottom. The milk's on top, but we don't know the milk for the new ratio. So, okay. All right, so then cross multiplication, 1.5 times 4.5. I don't know what that comes out to be. 6.75. Okay. And then 6x, and then we would divide both sides by 6. And so whatever 6.75 divided by 6 is, that's going to be our answer. I think I said round to the nearest tenth of a cup if you need to. What does it come out to be? So it's like 1.125, which would round to 1.1 cups. So just a little over a cup of milk would be what you want. All right. Cool. Questions on that one? Yeah.
Can you find the unit rate for that?
Yeah. The other way is you could go unit rates. So depending on which way did you do it? Did you do it that way?
No, I'm just
Yeah, you could. I mean, you could go so you could just do like 6 divided by 1.5, and that's flour per milk, basically, I guess. Flour per 1 cup milk. And so if you do 6 times 1.5, that actually divides nicely, right? I think, doesn't it? Because it's 4, right? So it's 4 cups flour for every 1 cup milk. But it's kind of weird to use unit rates sometimes because it's not always clear if you should multiply or divide. So then to get to your answer, what you'd have to do is well, I have 4.5 cups flour, so I'll divide by the 4 cups flour, and that would get you your answer. So sometimes the unit rates isn't actually really a super clear way to solve these problems. That's why I always just fall back on proportional equations. Unit rates work really nicely sometimes, and other times they don't. And the other thing too is if you calculate the unit rate the other way, then it would be multiplication. So it's like depending on which way you calculate your unit rate, it changes how you would have to use it in the context of the problem. Whereas with the proportional equation method, it doesn't matter which way you set up your fraction as long as you match the fraction on the other side. And so it's a little more straightforward. Okay? All right. Any other questions? Okay, so I'm going to give you some problems here. These are from all through chapter 6. And so there's some percentage stuff here, and there's some proportion stuff here.